Coterminal means just that, the same terminal side. So we know that the angle begins with the initial side corresponding to the positive part of the x-axis, and that the terminal side is whatever quadrant we say the angle lies in. So we have, remember from the work from last week, we have the four quadrants: first, second, third, and fourth quadrants, Roman numerals. All of the trig functions are positive in the first quadrant. Sine and its reciprocal cosecant are positive in the second. Tangent and its reciprocal cotangent are positive in the third. And cosine and its reciprocal secant are positive in the fourth quadrant. If we start first, second, third, and fourth, and we use the first letter of all sine, tangent, and cosine, we could pick four words like all students take calculus, all students take chemistry, all skiers take chairlifts, whatever you want to come up with, some pneumatic device to help you remember what quadrants they're positive in. So we're going to divide 2580 by 360. How many times do we go around in a revolution? We go around 7 times with 60 left over. So I have 60 degrees as the angle, dropping a perpendicular always to the x-axis, never to the y-axis. Now remember the special angles we worked with last week. The hypotenuse is 2. The side opposite the 30-degree angle is 1/2 the hypotenuse, which is 1. And the side opposite the 60 is the square root of 3. So the sine of 60 is equal to y over r. So it's equal to the square root of 3 over 2. So I want you to think of 4 pi as being 16 pi over 4. So we've gone around, and we've ended up here at 17 pi over 4 minus 16 pi over 4 is going to give you pi over 4 for that angle. So now dropping a perpendicular to the x-axis, the reference angle is pi over 4, which is 45 degrees. So the hypotenuse is 2, y is the square root of 2, and x is the square root of 2. Cosine is x over r. So the x value is the square root of 2, the r value is 2, so we're getting the square root of 2 over 2. Okay, first we have to determine what quadrant has the tangent being positive. I'm going to make the tangent, I'm going to change this up a little bit. Let's make the tangent equal to negative 4/5. So the tangent is negative and the cosine is positive. That means we must be in the fourth quadrant. And we always drop a perpendicular to the x-axis. So we have tangent is equal to y over x. So we have 4 and 5. Now don't always think that the 4 has to be the one that's negative. Just because the negative is with the numerator, be careful as we move to other quadrants. In this case it is y that's negative and x is positive. But don't always just put the negative with the numerator and think that's where it goes. So now we have the Pythagorean theorem. So we have to find r. So we have 5 squared plus negative 4 squared equals the radius squared. 25 plus 16 equals r squared. R squared equals 41. R equals the square root of 41. And sine is equal to y over r, but we need to rationalize. We always want to get rid of the radical in the denominator, so we have negative 4 square root of 41 over 41. Okay, so now we're looking at a reference angle, and it might not be 30, 60, or 45. So now we have 90 degrees, 180 degrees, 270, and 360 as the quadrantal angles. 250 is between 80 and 270, and drop a perpendicular to the x-axis. So the terminal side is at 250. 250 minus 180 gives us a reference angle of 70 degrees. The next we're working with 5 pi over 3, so I want you to think of denominators of 3. So I want you to think of 180 or pi as having a denominator of 3, which would be 3 pi over 3. And I want you to think of 2 pi with a denominator of 3 as being 6 pi over 3. And again, not changing to degrees. So therefore, 5 pi over 3 would put it in the fourth quadrant, because 6 pi over 3 minus 5 pi over 3 gives you a reference angle of pi over 3.